I'm Tom Occhino. Thank you, Chris, first of all. I'm going to talk a bit about how we do JavaScript application development at Facebook. We're going to do something a little different. Jordan is actually also going to present. He's going to do some of the technical stuff. I'm going to talk about the fluffy shit. I'll get it out of the way quick. First of all, we asked ourselves this question many, many times. How should we structure JavaScript applications? And more specifically, JavaScript applications that run in a web browser. We're using Node and doing all that fun stuff too, but I'm more interested in the user interface side of things, so that's what we're going to talk about today. There are a lot of JavaScript frameworks that aim to answer this question. These frameworks have allowed us to move the web forward as a real application platform. If Peter Higgins is in the room, I want to call out that Dojo's up here, because Dojo did it first, as he would say. Or Dojo already did that. But the consensus is basically that an MVC-style architecture is best. And it's not just MVC, right? It's MVVM, or as Angular calls it, model view whatever. I really like that one. I actually really like Angular in the declarative data binding. I think that's kind of the holy grail in terms of APIs. All of these architectures and frameworks have one thing in common, though, and that's models. So typically, models in these frameworks implement observable objects with an events API. Developers use bidirectional data binding to bind their views to their models. As your models change, your views can be updated. And as your views change, they can update the models, which then propagates out to other views. Excuse me. So this observable model pattern encourages mutation, though. And mutation is complex. So a few years ago, starting with our chat rewrite, we tried to start structuring our application a little bit differently. We wanted to minimize the amount of mutation that developers had to deal with. Mutation is a necessary evil. You have to deal with it. But we want to minimize the amount of mutation that developers have to code themselves. So let me show you what I mean by that. Here's the structure for a simple application. In this diagram, you'll notice that all updates go through a single flow. So all updates, including user input, they go through a single channel. This is one-directional data binding. Those updates eventually reach the views. And the simplest way that we have found, conceptually, to structure and render our views is to just try and avoid mutation altogether. So what I mean by that is, anytime any of your data changes, just blow away your view completely and re-render it from scratch. Now, I know what you're thinking. That's not going to work, right? The DOM can be slow. You know, browsers are going to be, it's going to be prohibitively expensive to try and do this, to try and just re-inner HTML everything every time anything changes, especially in a real-time app or something that's really interactive. So, you know, conceptually, this is what we're going for, though. This is what we want. We want to build something that gives us the conceptual simplicity of re-rendering from scratch on every single event, but, you know, without the overhead, because that's prohibitively expensive. So about 18 months to 2 years ago, I'm missing the exact date, we started working on a JavaScript library that helps us do that, and we call it React. So that was all the fluffy stuff. And now I'm going to let Jordan come up and talk about some of the more technical details of this. There you are.
Thanks. All right, so like Tomo was saying, one of the things that we strive for when we're building our component framework is that we want to minimize the amount of developer-facing mutations that the developer is exposed to. And so React takes a different approach in a few ways. The first is that it's highly declarative. And so that means that not just your initial rendering, but also a lot of your updates are implemented via some kind of a declaration. It's a non-mutative description of what your UI should be. Okay, so we don't have observable data binding inside of React. We don't ship with it. I imagine you could actually use it with React, but a lot of the things that you might reach to observable data binding for in order to implement, React provides a different way to do that, and declaration is the way that we do that. So along with React, we are shipping an embeddable XML syntax, and we're calling that JSX. So this is similar to a lot of the work and language proposals that might have happened in the past, but we're unique in a few ways, and I'll let you take a look at what that looks like first. Okay, so here we have React used with JSX. And so we are creating a message variable, and we're assigning it to a React div instance. And that has a nested inner div there, too. So these divs are not exactly what you're used to. They're not DOM nodes. So they're special React divs, and I'll get to why that's important. At the bottom there, we render it. So one thing that makes JSX unique is that it's a very lightweight transform. All we do is transform these tags into function invocations. So it's not quite as nice looking, but you can see it even preserves the line numbers. So if you pass this to your linter, it'll catch like tags that are out of scope. Your lint messages will appear in the right line and everything's low tooling is the key here. But JSX is also optional if you want to build with React. So if you like this, you can write that, but I think you guys would agree that this is a lot better. So React is more than just about DOM nodes and DOM components, but React is primarily a way for you to abstract reusable code and hide implementation details of your application UI. So the primary focus of React is allowing you to build custom components. So the way that you use a custom component is a lot like the way that you would use a div or a span. We can use the XML syntax JSX to instantiate it. And so we have XML attributes, text, and an on-action callback provided here. And these become the properties of your Vue instance or of your React component instance. And so you probably want to check out how we implement or define this action button. A couple of things just to note is that we make one call to react.createClass, and then we also supply a render function. So what this does is creates a class to model your component, and it will extend or it will mix in all the base functionality of the React base. So React is not an object-oriented focused framework, though. We use a little bit of inheritance just because that lends itself naturally to what JavaScript is good at. But other than that, the core paradigm here isn't object-oriented. So I thought I would call that out. So you can supply other methods here, and they get mixed into your prototype. And so the moment you define the action button, you can actually reference it. It becomes in scope, and your linter won't complain. If action button wasn't in scope, your linter would say, this is not defined. So it's a very JavaScript-centric language, this JSX. And so render has one purpose, and that is to describe your view at any point in time. So that doesn't mean just the initial render, but at any point in time. So let's go through what that might look like over a series of updates. Okay, so we're starting out with a shell here. We have an outer button and an inner span. So we want to do something interesting with the properties that we're given. We want to be able to interpret them into a user experience. So what we do is we take the properties text and route it down into the inner span. And the way you do that is you can refer to these XML attributes that are passed in via this.props. So you can see there in the center where we're routing the book flight text into the inner span. But these XML attributes don't just have to be strings because we're in JavaScript and JSX and React is JavaScript focused. So we have a function that we're being supplied here in the onAction callback, and we're routing that to the buttons onClick. So an action buttons onAction is a DOM buttons onClick in this case. And so it helps to view, at least initially, a React component as a transform from these properties into a user experience, and you can just kind of imagine these being routed to their proper locations. But React is more than just a routing tool. You can do any kind of transform or you can do any JavaScript expression that you want inside of these interpolation braces. So that means that we can uppercase the text, and so anytime the text changes, this will always be uppercased. So like I mentioned earlier, render isn't just your initial rendering, but it's actually your rendering over all points in time. So as your properties change, the render output changes, and then React satisfies your render function. It'll make sure that the user experiences render exactly as you've described at any point in time. And so what React will do is it will find the minimal set of DOM mutations needed to make that happen. So let's say that your text had changed. So React will find that the only thing that needs to change is that innermost span's text content. So I'll explain a little bit more about how that works. But the key here is that you can re-abstract these previously abstracted components. We already saw the action button, and that was a simple and stateless component. But you'll eventually want to build something more complex, something more like an application. It will have its own internal state. So let's do that. So this is the simplest stateful component that you could imagine. It's the counter. It has an increment and a decrement button. And you'll see that we're actually reusing our action button that we created in the last example. And so we have two action buttons, one that increments, one that decrements. So this is new. If you want to build an application and you don't just want simple stateless views, you want to be able to define some kind of a state machine. You want your component to be able to assume the role of a state machine in some way. And so state machines need an initial state. So getInitialState is a special function that React allows you to implement in order for you to define what your initial state is. So in this case, we're setting the count member of our state to be equal to the initial count property that was passed in. And the example there passes 4. So we're going to initialize our state to be 4. So this is where it gets really interesting. The same way that we could refer to props in our render function and assume that they're always up to date, because React ensures that, we can also refer to state inside of our render function and assume that they're always up to date. So anytime your properties or your state changes, render will remain satisfied by the React system. So the content of that H3 there will always show the states count. And you can put any expression there again. You can put a ternary that decides what to render there, special messaging depending on like certain counts. OK, so to make these state changes actually happen, we bind the add-to-count method to our action buttons on action. And so when we increment 1, we're going to add to count passing in 1, because we bound it there in the callback. And so what we do is we set state, which is like a state transition. If our components are a state machine, then set state is how you perform state transitions on the state machine. And what we do is we set the next count to be equal to the current count plus the delta. All right, so how does this work? So there's two main passes here, or there's two main stages to the React component life cycle. There's the initial rendering. And so what we do, for the sake of flexibility, is we compute a giant markup string. And so React will traverse your entire component hierarchy tree, and it will create a markup string that it injects into wherever you render it. Now, there's a second phase to that initial stage there. And that is that we instantiate all the backing objects and attach all the event handlers. And what's interesting here is that these two things can occur in two different places on your system, two different computers, anywhere in the world. So you could in theory, render the markup on a server and then attach all the event handlers and instantiate all the backing views on the client, two completely separate machines. We could talk a lot more about that too. But the second primary phase of a component's life cycle is when these changes in data happen. So we need to make the UI fresh, and that's what reconciliation is it's updating it's making sure that your UI is updated anytime any of your data sources change. And so how this works is that it recursively compares subsequent invocations of render, and it takes the outputs of those, and it creates the smallest diff possible to make sure that your UI is up to date. So if only one little DOM node changes, or if only one class name or one style attribute on a DOM node that's possibly 50 levels deep in your view hierarchy changes, we'll serialize these diff commands basically over this logical bridge to this other part of the system that will apply to that smallest mutation. And so again, just to illustrate that in more depth here, if this text changes from book flight to book hotel, only that span, the only DOM command that will ever execute is to make sure that that span's inner text is changed. We won't even read from the DOM, actually. OK, so anybody that's giving a presentation at a conference is going to show you the most contrived examples. And so React is no different. But there's also an escape hatch, or several escape hatches that you can tap into in the React system. So some of the things you're going to want to do is you're going to want to integrate with your existing frameworks or your existing code. And so we allow plenty of ways to let you do that. And another more interesting escape hatch that we have is a way for you to be able to help guide this process along. So React is finding this diff, the smallest possible set of DOM changes that need to be applied, and that can take some time. So what we allow is we allow you to prune out a lot of the search space and help React and help guide React along to find these smallest diffs. And so those are completely optional. You can put them in your code, or you can take them out, and the same application runs just faster or slower. So it's treating this optimization step as a completely separate part of development. It's not core. You don't start with the optimizations, but you identify the bottlenecks and apply them where necessary. Okay, so I'm going to kick it back to Tomo, and he's going to tell a little bit about the history of React and the future.
Thanks, Jordan. Yeah, so the interesting thing about that escape hatch is that's actually pretty important to being able to iterate on your product over time. So another hook that you get is basically at any point you can say, just give me a DOM node and let me write JavaScript. So one of the examples that we had up here was, and we just trimmed it for content, but like you can basically say, okay, I have this other plugin from some other framework that does like auto-growing text areas, or that does like an auto-completer. And you can basically wire those things up via that escape hatch really easily. And this is actually why this framework was able to be successful at Facebook. We didn't have to convert everything. We could use it kind of piecemeal. But yeah, I mean, this started a long time ago. This started probably 18 months ago, somewhere between 18 months and 2 years ago. And at this point, we're using this all over Facebook.com. If you've ever commented on anything on Facebook or liked anything, if you've ever talked in chat or integrated or used your buddy list, or even use your notifications. There's a bunch of different places where we've been using this for a really long time. And it's been working out really, really well for us. So about a year ago when Instagram joined Facebook, we had this, this is the first time that this ever happened to us. We had somebody else who wasn't on Facebook's infrastructure that wanted to use Facebook's infrastructure. And we've presented a bunch of stuff at JSConf in the past, and historically our excuse has kind of been, it's pretty tough to divorce things from our infrastructure. But Instagram joined us and they really wanted to use this, and they sort of acted like a forcing function for us. Rebecca made a great comment about writing your code as if it's open source. So what we started to do is we just went through all of React and all of the build steps and all of those all the tooling behind it, and we built it, or refactored it and rebuilt it such that it was able to be open sourced so that Instagram could use it on Instagram.com. In fact, Instagram.com was their first project that they wanted to take on after they joined Facebook. And in a matter of a week or two, they built all of Instagram.com profiles on this system, which was amazing for us. We were really excited about that. They basically, again, they acted as a forcing function for us to kind of get our house in order and divorce our infrastructure from this library and some other libraries. So all of Instagram.com is on React now. And it gave us practice with somewhat of an external client. So the logical next step for all the people that have been working on this is, we want to open source this. And actually, incidentally, we did that about a half hour ago. So if you check out Facebook, thank you. So again, I want to be really humble here. This is just something that we're using. It's something that works really well for us. We're really interested to get any feedback we can. Definitely check out the link. We're really open to feedback. There's a Google group, there's an IRC chat room, there's all sorts of on GitHub there's issues and stuff there. So that's React, and thank you.